consider polynomial and rational functions. We have a theorem for any positive integer n, limit extends to a, x to the power n minus a to the power n by x minus a equal to n into a to the power n minus 1. To illustrate using of this theorem, consider an example. Limit extends to 1, x to the power 15 minus 1 divided by x to the power 10 minus 1. In the theorem, we can see that the denominator is x minus a. So, for this example, the denominator must be x minus 1. Hence, dividing by x minus 1, we get limit extends to 1, x to the power 15 minus 1 by x minus 1 divided by x to the power 10 minus 1 by x minus 1. Using properties of limit, we get limit extends to 1, x to the power 15 minus 1 by x minus 1 divided by limit extends to 1, x to the power 10 minus 1 by x minus 1. For the first limit, we can see that a equal to 1. So, we get 15 into 1 to the power 15 minus 1, that is 14, divided by 10 into 1 to the power 10 minus 1, that is 9. And therefore equal to 15 divided by 10 equal to 3 by 2. Consider another example. Limit extends to 0, root over 1 plus x minus root over 1 minus x by x. This limit is of the form 0 by 0 and numerator is in irrational form. In that case, we will multiply numerator and denominator by corresponding irrational conjugate. So, in that case, we will multiply it by root over 1 plus x plus root over 1 minus x. So, we get limit extends to 0, root over 1 plus x minus root over 1 minus x into root over 1 plus x plus root over 1 minus x divided by x into root over 1 plus x plus 1 minus x. So, numerator is of the form a minus b into a plus b, that is a square minus b square. So, we get limit extends to 0, 1 plus x minus 1 minus x, and the denominator is x into root over 1 plus x plus root over 1 minus x. So, we get limit extends to 0, 2x by x into root over 1 plus x plus 1 minus x. So, x gets cancelled. So, we get limit extends to 0, 2 by root over 1 plus x plus 1 minus x. Now, putting x equal to 0, we get 2 by 2, that is equal to 1. Next, consider another example. Limit extends to 1, 2x minus 3 into root over x minus 1 by 2x square plus x minus 3. Here, putting x equal to 1, we can see that this limit is also of the form 0 by 0. Now, in the denominator, we can see this is a quadratic, so it can be factorized. So, 2x square plus x minus 3 can be written as 2x plus 3 into x minus 1. Again, x minus 1 can be written as root over x minus 1 plus root over x plus 1. Now, here root over x minus 1 gets root over x minus 1 gets cancelled. So, we get limit extends to 1, 2x minus 3 by 2x plus 1 into root over x plus 1. Again, putting x equal to 1, we get minus 1 divided by 5 into 2, that is minus 1 by 10. Next, consider limit of trigonometric functions. We have the theorem limit extends to 0, sin x by x equal to limit extends to 0, tan x by x equal to 1. To illustrate using of this theorem, consider an example. Limit extends to 0, 1 minus cos x by x. Now, we have the formula cos 2 theta equal to 1 minus 2 sin square theta, that is 1 minus cos 2 theta is 2 sin square theta. So, in the numerator, we can write 1 minus cos x as 2 sin square x by 2. So, we get limit extends to 0, 2 sin square x by 2 divided by x. Now, for using the previous theorem, the denominator must be x by 2. So, we can retain it can be written as limit extends to 0, sin x by 2 divided by x by 2 into sin x by 2. Now, using properties of limit, we can distribute limit. So, we get limit extends to 0, sin x by 2 by x by 2 into limit x tends to 0 sin x by 2. Now in the first limit, as x tends to 0, x by 2 also tends to 0. So we can use the previous theorem. So value of the first limit is 1, and for the second limit we can put the value of x equal to 0. So we get limit x tends to 0 sin x by 2 equal to 0. Therefore the answer is 0. Next, consider another example. Limit x tends to 0 tan x minus sin x by x cube. In the numerator it can be written as tan x into 1 minus cos x by x cube. Again 1 minus cos x is 2 sin square x by 2. So we get limit x tends to 0 tan x into 2 sin square x by 2 divided by x cube. Now for using the previous formula, we must be denominator in x by 2. So it can be written as limit x tends to 0 tan x by x sin x by 2 by x by 2 whole square. Now for adjustment we multiply by 2 and 1 by 4. So using the properties of limit we can distribute limit. So we get half into limit x tends to 0 tan x by x into limit x tends to 0 sin x by 2 by x by 2 the whole square equal to half into for the first limit we have the previous theorem, limit x tends to 0 tan x by x equal to 1. So half into 1 into limit x by 2 tends to 0 sin x by 2 by x by 2 whole square. Now again using the previous theorem we get the second limit is 1. So half into 1 equal to half. Now consider this example. Limit x tends to pi sin pi minus x divided by pi into pi minus x. In the previous theorem we have limit x tends to 0. So for tends to 0 we put pi minus x equal to z. In that case we get z tends to 0 as x tends to pi. So substituting value of x we get limit z tends to 0 sin z divided by pi into z. So 1 by pi into limit z tends to 0 sin z by z. Now limit z tends to 0 sin z by z is 1. So we get equal to 1 by pi. Next, consider limit of exponential functions. We have the theorem limit x tends to 0 a to the power x minus 1 by x equal to log e base a, where a must be greater than 0. In particular, limit x tends to 0 e to the power x minus 1 by x equal to 1. To illustrate using of the theorem, consider an example. Limit x tends to 0 e to the power 3x minus 1 by x by 2. Now to use the previous formula, the denominator must be 3x. So the limit can be written as limit x tends to 0 e to the power 3x minus 1 by 3x. For adjustment we multiply it by 2 into 3. Again using properties of limit we get 6 into limit e to the power 3x minus 1 divided by 3x. Also here as x tends to 0 we get 3x tends to 0. Now we can use the previous formula, that limit x tends to 0 e to the power x minus 1 by x equal to 1. So we get 6 into 1 equal to 6. Now consider the limits of miscellaneous functions, that is the limits of mixed of exponential, polynomial and trigonometric function. Consider limit x tends to 0 x into e to the power x minus 1 divided by 1 minus cos x. Now 1 minus cos x can be written as 2 sin square x by 2. Now we have a theorem that e to the power x minus 1 by x equal to 0. So we write it as limit x tends to 0 e to the power x minus 1 by x into x square by 2 sin square x by 2. Now it can also be written as limit x tends to 0 e to the power x minus 1 by x into x by 2 by sin x by 2 whole square, and for adjustment we multiply it by half and 4. Now using the properties of limits we get 2 into limit x tends to 0 e to the power x minus 1 by x into limit x tends to 0 x by 2 by sin x by 2 whole square. Now for the first limit it is 1, so we get 2 into 1, and for the second limit, as x tends to 0, x by 2 also tends to 0, so we get limit x by 2 tends to 0 x by 2 divided by sin x by 2 whole square. So we get 2 into 1 into 2 equal to 2. Next, consider another example. Limit x tends to 0 sin 4x by sin 2x. Since we have the formula sin x by x equal to 1, the denominator must be 4x. So we get limit x tends to 0 sin 4x by 4x and also 2x by sin 2x. For adjustment, we multiply it by 2. So we get limit x tends to 0 sin 4x by 4x into 2x by sin 2x into 2. Again, using properties of limit, we get 2 into limit x tends to 0 sin 4x by 4x divided by limit x tends to 0 sin 2x by 2x. Now for the first limit, as x tends to 0, 4x tends to 0, and for the second limit, as x tends to 0, 2x tends to 0. So for the value of the first limit is 1 and also the value of the second limit is 1. So we get 2 into 1 equal to 2. Next, consider limit x tends to 0 log of 1 plus 3x by e to the power x minus 1. Since we have a formula limit x tends to 0 log 1 plus 3x by x equal to 1, so use that formula, the denominator must be 3x. So we get limit x tends to 0 log 1 plus 3x by 3x into e to the power x minus 1 by x. For adjustment, we multiply it by 3. Again, using the properties of limit, we get limit x tends to 0 3 into log 1 plus 3x by 3x divided by limit x tends to 0 e to the power x minus 1 by x. Now as x tends to 0, 3x also tends to 0, so we get 3 into limit 3x tends to 0 log 1 plus 3x by x, and also denominator, value of the denominator is 1, so we get 3 into 1 by 1 equal to 3. Thank you.